To effectively prepare for the major calculations portion of the Washington State Electrical Administrator's test, there are several resources and strategies to consider. Firstly, the Electrical Code Calculations Manual published by the National Electrical Contractors Association offers comprehensive calculations for electrical installations, including major calculations. It provides step-by-step instructions and examples, making it a valuable tool for understanding the calculation process. Secondly, the Electrical Calculations, a practical guide for electricians and engineers by Donald F. Bender, explains electrical calculations in detail, again including major calculations. This resource includes practice problems and solutions, allowing you to test your knowledge and reinforce your understanding. Thirdly, the Code Calc Electrical Calculations Manual from American Technical Publishers offers a structured approach to electrical calculations, also including major calculations. It provides a reference library of articles and calculations, making it a useful resource for quick reference and in-depth study. Fourthly, it's crucial to thoroughly review National Electrical Code Annex D Exception 5. This section provides specific calculation methods for ungrounded systems as required by Washington State. Supplement your review of Annex D Exception 5 with other resources to ensure complete understanding. Fifthly, the Washington State Electrical Administrator Exam Study Guide from Pro Design Engineering is tailored specifically to the Washington Administrator's test, including major calculations. This study guide provides practice questions and explanations, allowing you to familiarize yourself with the test format and content. Sixthly, consider using laser grade practice tests. Practicing with actual laser grade test questions can help you identify your strengths and weaknesses. Analyze your performance to identify areas where you need further improvement. In addition to these resources, there are some general tips that can help you succeed in the major calculations portion of the test. Firstly, familiarize yourself thoroughly with the National Electrical Code and Annex D Exception 5. Understanding the code requirements is essential for performing accurate calculations. Secondly, choose the calculation method that is most straightforward and appropriate for the given scenario. There may be multiple ways to solve a problem, but some methods may be more efficient or easier to understand than others. Thirdly, show all your work clearly in your calculations. This will help you avoid errors and make it easier to review your work. Fourthly, practice regularly to build confidence and accuracy. The more you practice, the more comfortable you will become with the calculation process. If you have any doubts, seek clarification from a qualified professional. Do not hesitate to ask for help from a licensed electrician or electrical engineer. To further clarify some key concepts and ensure a strong foundation for tackling major electrical calculations, let's delve into some important aspects of electrical theory and application. Understanding Ohm's law is absolutely fundamental. Ohm's law describes the relationship between voltage, current, and resistance in an electrical circuit. The formula is volts equals amps times ohms. Knowing this relationship is critical for solving many electrical calculations. Another essential concept is Kirchhoff's laws. Kirchhoff's current law states that the total current entering a junction must equal the total current leaving the junction. Kirchhoff's voltage law states that the sum of the voltages around any closed loop in a circuit must equal zero. These laws are invaluable for analyzing complex circuits. Power calculations are also crucial for electrical work. Power, measured in watts, is the rate at which electrical energy is transferred. The formula for power is watts equals volts times amps. Understanding how to calculate power is essential for determining the size of conductors, of current protection devices, and other electrical equipment. When performing electrical calculations, it is imperative to adhere to the National Electrical Code. The National Electrical Code provides specific requirements for electrical installations, including calculation methods. Familiarize yourself with the relevant sections of the National Electrical Code, such as Chapter 2, Wiring and Protection, and Chapter 3, Wiring Methods and Materials. The National Electrical Code also provides tables for conductor ampacity, conduit fill, and other important parameters. Learn how to use these tables correctly to ensure compliance with the code. For example, National Electrical Code Table 310.16 provides ampacity ratings for conductors based on their size, insulation type, and ambient temperature. When selecting conductors, it is essential to choose a size that can safely carry the intended current. National Electrical Code Article 220 covers branch circuit, feeder, and service calculations. This article provides detailed instructions for calculating the load on electrical systems. Familiarize yourself with the different methods for calculating load, such as the standard method and the optional method. Demand factors play a significant role in electrical calculations. A demand factor is the ratio of the maximum demand of a system to the total connected load of the system. Demand factors are used to reduce the calculated load on feeders and services. National Electrical Code Article 230 covers service calculations. This article provides requirements for the size and installation of service conductors and overcurrent protection devices. Ensure that you can accurately calculate the service load for different types of occupancies. Voltage drop is an important consideration in electrical calculations. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. National Electrical Code Section 210.19a provides guidelines for voltage drop in branch circuits. It's important to perform voltage drop calculations to ensure that the voltage at the point of utilization is within acceptable limits. Short circuit current calculations are essential for selecting overcurrent protection devices with adequate interrupting ratings. A short circuit current is the maximum current that can flow in a circuit under fault conditions. Perform short circuit current calculations to determine the appropriate interrupting rating for circuit breakers and fuses. Grounding and bonding are critical for electrical safety. Grounding provides a lower impedance path for fault current to return to the source, while bonding ensures that all metallic parts of an electrical system are at the same potential. Familiarize yourself with National Electrical Code Article 250, grounding and bonding, and understand the requirements for grounding electrodes, equipment grounding conductors, and bonding jumpers. Transformer calculations are often required in electrical design. Transformers are used to step up or step down voltage levels. Understand the relationships between voltage, current, and turns ratio in a transformer. Calculate the primary and secondary currents and voltages for different transformer configurations. Motor calculations are also a common task for electrical professionals. Motors are used to power a wide variety of equipment. Calculate the full load current, starting current, and overload protection requirements for motors. National Electrical Code Article 430 covers motors, motor circuits, and controllers. Power factor is a measure of how effectively electrical power is being used. A low power factor can result in increased energy costs and reduced system capacity. Understand how to calculate power factor and how to improve it using power factor correction capacitors. Harmonic currents are non-sinusoidal currents that can cause problems in electrical systems. Harmonic currents can be generated by nonlinear loads such as electronic equipment and variable frequency drives. Understand the effects of harmonic currents and how to mitigate them using harmonic filters. When performing electrical calculations, pay close attention to units. Ensure that you are using the correct units for all quantities such as volts for voltage, amps for current, ohms for resistance, and watts for power. Convert units as needed to ensure consistency in your calculations. Use a calculator or computer software to perform complex calculations. These tools can help you avoid errors and save time. However, it is important to understand the underlying principles of the calculations and not rely solely on the software. Double-check your calculations to ensure accuracy. Even a small error can have significant consequences in electrical design. Review your work carefully and ask a colleague to check your calculations as well. Keep a record of your calculations and assumptions. This will help you track your work and make it easier to review and revise your calculations as needed. Stay up to date on the latest version of the National Electrical Code and any applicable local amendments. The National Electrical Code is updated every 3 years, and it is important to be aware of any changes that may affect your work. Attend continuing education courses and seminars to stay current on electrical codes and standards. These courses can help you improve your knowledge and skills. Consider becoming a certified electrical professional. Certification demonstrates your competence and commitment to the electrical industry. Seek guidance from experienced electrical professionals. Mentorship can be a valuable way to learn from others and gain practical experience. Join professional organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the International Association of Electrical Inspectors, or IE. These organizations offer opportunities for networking, education, and professional development. When preparing for the Washington State Electrical Administrator's test, it is important to focus on the areas where you are weakest. Identify your knowledge gaps and spend extra time studying those topics. Take practice tests under timed conditions to simulate the actual test environment. This will help you improve your time management skills. Get a good night's sleep before the test. Being well rested will help you think clearly and perform at your best. Eat a healthy breakfast on the day of the test. This will provide you with the energy you need to focus and concentrate. Read each question carefully and make sure you understand what is being asked before attempting to answer it. Eliminate any obviously wrong answers to narrow down your choices. If you are unsure of the answer to a question, make an educated guess and move on. You can always come back to the question later if you have time. Don't spend too much time on any one question. If you are stuck, move on and come back to it later. Manage your time effectively to ensure that you have enough time to answer all the questions. Stay calm and confident during the test. Believe in yourself and your abilities. Remember that you have prepared for this test and you are capable of passing it. By following these resources and tips, you can increase your chances of success on the major calculations portion of the Washington State Electrical Administrator's test. Remember to focus on understanding the underlying principles, practicing regularly, and seeking clarification when needed. Good luck. To reiterate a few essential calculation areas, understanding conductor sizing per National Electrical Code 310.16 is crucial. This table provides ampacities based on conductor type, insulation, and ambient temperature. Correctly applying adjustment and correction factors for ambient temperature and the number of conductors in a raceway is vital for safe installations. Another key area is overcurrent protection. Calculating the correct size of circuit breakers or fuses for various loads, in accordance with National Electrical Code 240.4, prevents overloads and short circuits. Short circuit current calculations are another critical area. Knowing how to determine available fault current at different points in a system, following the methods outlined in resources like the Busman series, ensures that overcurrent protective devices have adequate interrupting ratings. Voltage drop calculations are also indispensable. Using the formulas provided in National Electrical Code Chapter 9 and other resources, and considering conductor length, current, and impedance, you can maintain voltage within acceptable limits, ensuring proper equipment operation. Grounding and bonding calculations, as dictated by National Electrical Code Article 250, are paramount for safety. Properly sizing grounding and bonding conductors and understanding grounding electrode systems is essential for minimizing shock hazards. Finally, be adept at performing motor circuit calculations as outlined in National Electrical Code Article 430. This includes determining full load current, branch circuit protection, conductor sizing, and overload protection for motors of various types and sizes. Mastering these calculations, along with thorough knowledge of the National Electrical Code and its application, will significantly improve your ability to successfully navigate the major calculations portion of the Washington State Electrical Administrator's test.